Hello everyone, welcome to this video. In this video, we shall be looking at an example which involves the order of some element in the direct product. So here the question is, we need to find the number of elements which are having order 5 in the direct product of two groups. One is Z25. This is the group under addition modulo 25. And another group is addition modulo 5, right? So when we take their direct products, we need to determine how many elements would be there in this direct product which would have order 5. So in the previous video, we have studied about this result, which states that the order of such an element in the direct product is calculated as the least common multiples of the orders of each components of the element. So here we need to find all such elements G1, G2 up to Gn, right, such that this order is equal to 5. So that means this LCM has to be 5, right? So that means we need to find, because there are only two groups, so we would have only two elements in our tuple, right? So we have A and B in this direct product. In this direct product, we need to find the elements. Now using this result, we would have the property that the order of the element A comma B would be equal to the LCM of the order of A and the order of B, right? So using this result here, because in this case we are required to count all such AB such that this the order of this element AB should be 5. So how many such A comma B would be there? That is our task. So in order to do that, we'll make use of this property. The left hand side is equal to 5, so that means the right hand side should also be equal to 5. So that means we need to calculate or count the number of all such elements A comma B such that their LCM, that means the LCM of order of A and the order of B is equal to 5, right? So now how can we obtain 5 as the LCM? Either we have both the numbers as 5, so then 5 would be the LCM. Either we have one as 5, another as 1, right? Or we have the first one as 5, the second one as 1. So only these possible combinations are possible such that we would obtain their LCM as equal to 5. So that means either the order of A should be 5 and B should either be 5 or 1. Its order should either be 5 or it should be 1. Or we may have the case where the order of B is 5 and A could be any of the 1. Its order could be 5, its order could be 1. So let's consider the case which are mutually exclusive to each other. So that means the cases which do not repeat each other. So you see the case 5 and 5. The order of A is 5 and order of B is 5 is covered in this case, and the order of B is equal to 5, order of A also 5 is also covered here. So we will not take this case in the second part. So in the first part, we consider that the order of A is 5 and B could have the order 5 as well as 1. So when this element A would have order 4, so A is taken from this group Z25, which contains 25 such elements. Now from this 25 elements, we need to check for that particular element which would have order 5, right? So there are 4 such elements, namely 5, 10, 15 and 20. Why? Because when we take the order of 5, so now here the operation is addition modulo 25, right? Addition modulo 25. So that means in order for any element to have an order 5, we need to add that element 5 times and take mod 25 of it, right? So that means in this case we need to add 5 times, which is 25, and then take mod 25 of it. So mod 25 or 25 would give you 0, which is the identity of this group Z25, correct? Next, you can see for the second element, when you add this second element 10 5 times, because 5 is the order, so you would have 50, and when you take 50 mod 25, that is again 0, which is the identity of Z25. Similarly for 15 and similarly for 20, right? So we have 0 and 0. So therefore these are the 4 possible numbers for which we may have the order as 5. right? Moreover, for B, the order of B to be 1 or to be 5, we are taking B from this group Z5, and Z5 contains these 5 elements within it. Now from these 5 elements, we need to see for that element which has order 1. So that means it is added once to itself. It is just added once, so that when we take mod 5 of it, we would have the identity of the group, which is 0 in this case, because we are taking addition modulo 5, right? So here we have only one choice, that is the number 0. Why? Because 0 mod 5 would be 0, because the order here is 1. Similarly, when the order of this element B is 5, in that case we would have 4 choices, namely 1, 2, 3 and 4. Why? Because when you add 5 times here, you would have 5, and then you will take mod 5 of it. Why? Because we are in Z5. So 5 mod 5 would be equal to 0. Similarly, for the element 2, when we add 2 5 times, we would have 10 here, and we will take 10 mod 5, which is 0, which is again the identity of Z5. Similarly, for 3, when you add 3 5 times, you would have 15. 15 mod 5 is again 0. And when you add 4 5 times, you will have 20. 20 mod 5 is again 0. So you see, all these 4 elements have the order 5 in the group Z5. So therefore, the possible choices for A, they are 5, 10, 15 and 20. So there are in total 4 choices, and there are in total 5 choices for B. One is this 0 and another one is this 1, 2, 3, 4. So in total we have 4 into 5 elements, which would give us the order 5 for the element A comma B, right? So what all possible orders could be, elements could be there? 5 with 0, 5 with 1, 5 with 2, 5 with 3, 5 with 4. So we have these 5 elements here. Similarly, for the element 10, we would have 10 with 0, 10 with 1, 10 with 2, 10 with 3, 10 with 4. So 10 is the first element here, and 0, 1, 2, 3 and 4 is the second element. Similarly, for 15 and similarly for 20, we would have 5 elements more here. So in total, we would have 20 such elements for the first case. For the second case, now we are taking the order of A to be 1 and the order of B to be 5, and we are not taking this case the order of A as 5 and the order of B as 5, because this case has been considered in case 1, right? Okay, so now for the order of A to be 1, A has to be selected from Z25, and in Z25 we have in total 25 elements. So there is only one choice for A here, which is the identity element, which is the 0. Why? Because when you take 0 mod 25, you would have 0 here, correct? And there are 4 choices for the element B, because we wanted to take the order of B as 5, and we are taking B from Z5, which contains 0, 1, 2, 3 and 4, right? So what these elements are 1, 2, 3 and 4. Why? Because the argument is similar as we have done in the previous case. So because when you add 1 5 times, you will have 5, and when you take 5 mod 5, that would be 0, which is the identity of the group. Similarly, for 2, 3 and 4, we would have the same result. So therefore, in this case, we have 4 elements of order 5. Why? Because we have just one element 0 here for A and 4 elements for B. For 0 would go with 1, 0 would go with 2, it would go with 3 and it would go with 4. So that means we would have 0, 1, 0, 2, 0, 3 and 0, 4 as the elements which are having order 5 in this case. Hence, in this direct product, we have in total 24 elements which would have order 5. And hence, we are able to calculate the number of elements having order 5 in this direct product by making use of the result that we have studied in the previous video. So I hope you understood this example well. Well, that is it for this video. Thank you for watching.